Okay, now we're doing 6.1 basics probability concept. So probability is the number of the events divided by the total number of the events, or number of outcomes divided by total number of the outcomes. Okay, let's just do an example. Let event A to be point awarded to player A in some product game is the outcome that make up event A. So I can make a chart like this for the sum and product. Let's say 1, 2, 3. I have the number 1, 2, 3, right? And the sum of these numbers. Say you have 1 plus 1 is 2. So you write it here. 1 plus 2 is 3. 1 plus 3 is 4. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3, 5. 3 plus 1, 4. 3 plus 2, 5. 3 plus 3, 6. So this is the total outcome that I have, right? Total outcome is what? 1, 1, 1, 2, 1, 3, 2, 1, 3, 1, okay? Then let's say you have a toss and you do it, right? And for a product, the same thing. 1 multiplied by 1 is 1. 1 multiplied by 2 is 2. 1 multiplied by 3 is 3. 2 multiplied by 2 is 1. Sorry, 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. 2 multiplied by 3 is 6. 3 multiplied by 2 is 6. 3 multiplied by 3 is 9. So this is what we have. So we want to see for which of these pairs the sum is greater than the product. So the sum is here. See here? Here is the sum is greater than the product here. Here we have 3, so sum is greater than the product there. Therefore, here is the same thing. Sum is greater than the product here. 3 to here again, sum here is greater than the product. Is 4, they are the same, 4 and 4 the same. 5, 6. So here's the product is bigger. 4, 3. Again, here sum is greater than the product. 5, 6. So product is here bigger. And 6, 9. The product here is bigger. So totally 1, 2, 3, 4, 5 events. The sum is greater than the product. So what was this event? 1, 1. As you see here. 1, 2. 1, 3. There. 2, 1. And 3, 1. So these outcomes, you can write event A is that the sum is greater than the product. So we can go through this. The empirical probability of the particular event is called experimental or relative frequency probability. It's determined by dividing the number of the times that that event actually occurred by number of the trials. So when you do the experiment, you have a coin, right? You want to toss it, right? Or you toss the cube for the gaming. So this is kind of experimental. Number of the outcome divided by total outcome will be the probability. For example, you had found that the first 10 trial, the product was greater than the sum 4 times, then the empirical probability of the event would be 4 over 10. For the previous game, you know, the total is what? 1, 2, 3, 1, 2, 3 is 9, right? The 9 things. So what is the probability of that? Since 1, 2, 3, 4, 5 of that is the sum greater than the product. What is the total outcome? The total outcome is 3 multiplied by 3, right? Which is 9. The probability that the sum is greater than the product is 5 over 9. The desired outcome divided by the total outcome. So this is the theoretical, but when you actually do it, it would be different, right? You're doing that experimentally. Let's say you have a three-sided shape, and on each side say 1, 2, 3, and you actually do it. You get two numbers, you see the product and multiplication of that, and you see 4 of those 10 trial is the product, the sum is greater than the product. So the probability of that would be 4/10. So here is P of A, the probability of event A is the number of that event divided by the total event. So as I said, the event that the sum is greater than the product is 5, and the total is 9. Determine the theoretical probability for each key event in some product game. See, since we did it with a table, we can do it like for a tree diagram. The first number is 1, 2, 3, right? The second one would be 1, 2, 3. So you have to put the 1, 2, 3 here and here as well. So product of that 1 multiplied by 1 is 1. See under the product. 1 plus 1 is 2. See under the sum. 1 multiplied by 2 is 2. 1 plus 2 is 3 here. 1 multiplied by 3 is 3. 1 plus 3 is 4. We do the same thing for all of this, and we'll list the sum and the product here. And you just note the items that the sum is greater. 1, 2, 3, 4, 5. So you just spot those that the sum is greater than the product. Therefore, the 5 event, the sum is greater than the product, and the total event is 9. You see, like we have a 3 number for the first and 3 number for second. 3 multiplied by 3 is 9. Similarly, event B is when the product is greater than sum. The product greater than the sum event is 1, 2, 3. That's why the probability that the product is greater than the sum going to be 3/9. 9 is total outcome. And then the C is when both are the same. So we just have one event there. And the product and sum are equal. So it's going to be 1/9. If you noted, if you add all of the probabilities, 5/9 plus 3/9 plus 1/9, it adds up to 1. 5 plus 3 plus 1 is 9. 9/9 is 1. So if you add all probability, it needs to add up to 1. Makes sense. It should give you all possible probabilities. Now here is another example. Mandy board games involve a roll of 2 6-sided dice to see how far you may move your pieces or counter. What is the probability of rolling total of 7? So on this side, I put one of my dice from 1 to 6. Second dice is from 1 to 6. So we have to add them. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3, 4, and so on. 2 plus 1 is 3. 2 plus 2 is 4, and so on. You just add them and you just fill this table. What's the probability of the rolling total of 7? You just need to spot those 7s here. See, 1, 2, 3, 4, 5, 6. I have 6 outcome. 7. What is the total? 6 multiplied by 6, which is 36. I have 36 in totally my events, and 6 of them you're rolling 7. So 6/36, you can simplify it. 1/6 is the probability of rolling 7. So here, this is a total space, the outcome A, and whatever it is not A, we call it A prime. A plus A prime, the probability of A happening plus the probability of A prime happening should be add up to 1 because it gives you total probability. So probability of A not happening, you just put the PA to the other side, it's going to be 1 minus P of A. Probability of A not happening is equal to 1 minus the probability of A happening. The complement of an event is the A prime. So we call A prime, here is PA prime is complement event. What's the probability that the randomly drawn integer between 1 and 40 is not a perfect square? It's hard to just list them and say find which number is not perfect square. It's better to find a number that is perfect square first, and then find the complement of that. So I know 1 power 2 is 1, 2 power 2 is 4, 3 power 2 is 9, 4 power 2 is 16, 5 power 2 is 25, 6 power 2 is 36, 7 power 2 is 49. 49 gonna exceed 40, so just stop there. But these numbers are the numbers that is less than 40, right? And is kind of perfect square. So the probability of having perfect square is 6 over total number is 40. It's 3 over 20. And the probability that the number is not perfect square is going to be 1 minus the probability of those numbers are perfect square. So you just find a complement of this probability is 1 minus 3 over 20. Common denominator 20 minus 3 is 17 over 20. So if you just convert it to the percentage, it's 85%. And make sure you know how to do that. If I want to convert 17 over 20 to the percentage, I just multiply that by 100. And you do that, you get 85%. Subjective probability, the third basic type of probability is estimate of a likelihood based on intuition, experience, and educated guess. For example, we say that 90% confident of passing the next data management test. Subjective probability of the figure in everyday speech expressions such as, I think the team has only 10% chance to win. I think tomorrow is like a 70%. I'm sure that tomorrow going to be rainy. So those are based on estimate of likelihood, like guessing. It would be the subjective probability. So let's just look at this example. Estimate the probability that the next pair of shoes you buy will be the same size as the last pair of shoes you buy. But is it likelihood? So probably there is a small chance the size of your feet change significantly, or that different style of shoes may fit you differently. So 80%, 90 would be a reasonable subjective probability that your next pair of shoes will be same size as your last pair. Because let's say you are adults, right? So each year your size of the shoe is not going to change much, right? So it's 80% or 90% likelihood that it will be the same size. Just guessing. And expression baseball team will win the World Series in their first season. Expansion team, so it's going to be very no experience, right? It has a very low probability, kind of 0 probability to win the World Series, of course. The next person to enter a certain coffee shop will be male. It's going to be 50-50%. Like you don't know, you just can get that. And you can guess that it's 50 chance that the next person is going to be male. Okay. So again, you do the even number questions and submit your answer to teacher.